Hello dear students, in this lecture we will see the properties of discrete Fourier transform. In last few lectures we have seen what exactly discrete Fourier transform is, what is the formula for discrete Fourier transform. We have solved also some problems based on discrete Fourier transform. Today we are going to see some properties of discrete Fourier transform. Like Fourier transform, some of the properties of discrete Fourier transform are similar. So first property is periodicity. If xk is an endpoint DFT of Sn, then if xn is the given signal and endpoint DFT is indicated by xk, then what periodicity property says? It said that xn plus n is equal to xn or xk plus n is equal to xk. So if the original signal is shifted by n, then the transform signal also shifted by n units. Next property is periodicity property. If xk, x1k and x2k are the endpoint DFT of x1n and x2n, and a and b are the arbitrary constants, then linearity property says that a into x1n plus b into x2n. After applying the DFT, we get a capital X1k plus b capital X2k. That means if the original signal is multiplied by the arbitrary constants a and b, then after applying DFT, the resultant signals are also multiplied by the same arbitrary constants. This is the linearity property. Shifting property. In this shifting property, the original signal is shifted with some amount. Let xpn is a periodic signal with period n. Xpn is equal to summation t is equal to minus infinity to infinity xn minus ln, where L is the number of samples. Now, if we shift the sequence xpn by some unit k to the right, so the resultant signal will be xpn is equal to xpn minus k is equal to summation t is equal to minus infinity to infinity x of n minus k minus ln. So here it is very simple property that if original signal is shifted with the k amount on the right side, the signal after DFT will be also shifted by the same amount in the right direction. So this is the shifting property. Next property is convolution theorem. Now let us see what convolution theorem says. So if x1n x1 omega and x2n is x2 omega, then we can say xn is equal to x1n into x2n x1n. After applying DFT, we get x omega is equal to x1 omega into x2 omega. So convolution property says that if we multiply the signal x1n into x2n, so the resultant DFT will be also multiplied by this, also multiplied x1 omega into x2 omega. So x1n after applying DFT, if we get x1 omega, and x2n after applying if we get x2 omega, then after convolution of x1 x2 we get xn is equal to x1 into x2n into x1n. We get x omega is equal to, that is resultant convolution after applying the convolution theorem, the signal will be x omega and convolution theorem will be x omega is equal to x1 omega into x2 omega. So this is the convolution theorem of discrete Fourier transform. Thank you for listening.